Hi, Jason. How are you? We'll get started in a minute, okay? Okay, so hi, Ethan. How are you? Okay, so we'll go ahead and get started. All right, so this week we are going to cover optimization in Python. I'll go ahead and share screen here. And I think people will be able to join us soon. Okay, so you will find the notes, which is on chapter 2. You will find that here. Okay, so oh, it says back. Let me reload that. Okay. You can download the document. The notes information is there. And then I will release the lecture video tonight and tomorrow. So you will find, I also linked the video from last semester there, but I will relink in the case if there's any updates. So the assignments that we're going to address is going to be Unit 3 assignment, which is on Chapter 2, and we're going to refer to our notes. So in this week's notes, we're going to work with a little bit with data structure and looking at algorithm when we implement algorithm, how to use effective data structure. So in Chapter 2, it starts with algorithm, and this is just a procedure on how we will be able to build out our program or use our program to solve a problem. So in any application, you would have procedures or step-by-steps in how you would implement step-by-step to be able to solve your problem, right? In the past, we see this, we only wrote snippets of the code in the last week just to do some tests. And so this week, we're going to take a look at how effective is an algorithm when you're using different type of data structure. So an algorithm can be run multiple times to be able to assess, right, computational complexity, which is the resources that's used to perform a certain task. Meaning that when you write a functions or when you implement a container, like a list or a doubly linked list, and we'll talk about that, how the program or the Python interpreter is able to access the elements in your container. Like if I need to use a for loop to iterate through and obtain values of all the elements in that container. So we look at time complexity, which is the computational complexity, to look at the amount of time to run our algorithm. Now, last lab, we touched on using timeit in Linux. And so when you're using the timeit module, you can let it print out the amount of time that's able to measure the average time taken. But in analysis for application, we want to look at not the average time, but the most amount of time that it would be taken. That means that in the worst case scenario, what is the time to use for the application, how the application is running and the amount of time. So in this example that you would see is that we are going to use X in range, and we want to print out the value for X, and we want to time it. So by the default, we're going to get best out of 3, and it's going to put through 100 loops, and that's going to be our end value here. So it's going to loop 100 times. And it tells us that it takes 11.1 millisecond per loop. In the second part of this example, you see that we are going to access only 10 elements. So your end value here is less than the first. So you only see 10 here. Now, we don't want to just loop it through 10 times. We want to use a higher amount of loops so we can get more accuracy. So the more you loops, the more consistent you're going to get in the average time. Now, the time it module, the way it's designed, is going to give you the average, the best out of 3. So that's the best scenario, right? But in application analysis, I said earlier that we want to look at the worst case scenario, because for the slowest system, right, with the least amount of resources, we want to look at how the application is going to be used in that system. What is the amount of time that it's going to be used to perform certain tasks for that system? So in the second part of the example, we see that it takes 1.09 millisecond per loop as we reduce the end value here. So we can see that it really depends on the number of input, especially if you're using iteration. That means that you would access, right, the elements in that container or that group one by one. So it is a linear computation. Now, in the first question, so I'm going to flip to the assignment so we can address the first question. So in the first question, it asks you, what is used to describe the amount of time to run an algorithm? And we know that it is time complexity, which is going to measure the amount of time for an algorithm in our applications. So if we assess, so the higher the value for n, so if you have a larger container with many elements, so let's say 1,000 elements, compared to a smaller container that contain 10 elements, you do see that the end value for the 1,000 is going to take longer time for the loops. So it is dependent on the number of input. So in the second question, it asks you to look at the given program and determine the time complexity of the program. So here you have a container named numbers, and it is a list. How do we know it's a list? Because it's using the square bracket. That's the list. And these are the values. So if you look at the number of elements here, 2, 4, 6, 8, 9, you have 9 elements in that list. And to continue with the program, we initialize a variable called total, and we are going to use it to store the running sum of the elements. So as we look through, we're going to add up the values, right, for each of the elements. And by the n, which is the 9th element, we would have the complete total. So with that, we would have a for loop for I in numbers for the element in the list. We are going to increment the element values by adding them, right? So the first loop, the second loop is going to take 6 plus 5, and then it will continue with the third, adding the value for the third element. And as we do that with the for loop, we're going to print the total. And then at the end, we are going to get the sum, which is the complete. So to look at the time complexity for this, we would look at the number of input, which is the number of elements in that container, which is 9. If you count them up, that will be 9. And the way that we denote the time complexity is we're going to use the big O notation. So O of n is going to represent the time complexity, where n is the number of the input for the elements in the list. In this case, that will be 9. So if I need to access one element, which is the first one or the 8th, any of the element on the list, it will be O of 1. So if I'm just going to put a note here. If one element is accessed, we would have O, the big O notation will be 1, because it's going to only go to that index and retrieve that value. Now, if you use the built-in method for Python package, for example, if I want to pop, right, the last element, take it out of the list, it would still be O of 1, because what it does is it's going to go in, complete that one task for that one element and remove it from the list. Now, when you do a pop in Python, what will happen is the list is going to shrink down as it gives this back to the system, the space, and we would remove that element value. So if we access any element, whether we remove or we insert an element, or if we go and find the value for the element, you would have the O of 1. Whereas in this case, when you iterate through the total of 9 elements, that will be O of n or O of 9, because it needs to access each of the elements. So the n value is 9. Okay. Now, if you put it into your Linux terminal or your Mac OS terminal and you use the timeit module, you can do it like the example where you call timeit and you want to loop through, and it's going to generate the best out of 3 by default. And it's going to give you the time that it would take to access, right, the elements. Okay, so to really determine the time complexity, we don't necessarily have to produce milliseconds at this point. We want to understand that it is the big O notation that's going to denote, right, the iteration of our container as a list. So this is your answer. Any question? Okay, so coming back to the notes here, it talks about the big O notation. So this is a method to really determine how fast your algorithm is, hence time complexity. We measure the algorithm by time. And in our system, we would use millisecond using timeit module. Now, in other cases, when you're using other modules, it might calculate it in a different time unit. So if the operation doesn't depend on the time input, like what we talked about when it's accessing only one element, you would have O of 1. That means that no matter how much data, the time will run is always going to be the same. So if I access the first element in our assignment here, sorry. If I access the first, which is index 0, that will be the same amount of time that I would need to access the later elements, as it is only one operation. Okay, so it will be O of 1. So in question 3, it tells you that given the program from question number 2, what is the time complexity to access any element in the numbers list? And we stated that in the previous, so that will be O of 1 time. is the time. So it doesn't matter which element you access, it will still be O of 1, as we're only going to go to one specific index, as that will be only one input. Any question? Okay, so before we get to the next module from the notes, okay, so here we also see enumeration being used here. So that will be your input for the range. So again, this is O of n, and for our range, that will be 10. So n is the size of your input in the array or the container. So in the next part, it tells you here that in these cases, algorithm may have different best case, average case, and worst case running times. So when you write up documentation for application for its analysis, you want to refer to the worst case running time, as we said that it could be on the worst case scenario on the slowest system with the least amount of resources. Now, when using a certain module, it might give you only the average case or the best case. So we have to select the type of tools that's appropriate for what we're trying to measure. So in the worst execution of the algorithm, we would look at the worst case, and in the case that it is infinitely looping, that could also be an infinite value. So if you write a while loop that's infinitely looping, right, through the container and keep accessing, so when it gets to the last element, it returns back to the first, right? Like, for example, I can use continue, and then it's going to come back and it's going to keep looping again. So in that case, your worst case scenario is going to be an infinite value. And just like any other programming language, when you look at Python application analysis for optimization, you would use the big O notation to really determine, right, your time as far as how we can measure our application performance, time complexity, big O notation. So here I also provide a table, right? As we talked about O of 1, that will be a constant. And in some other cases, you see order growth in log B of n. So in any logarithmic or for any b, so in the case where you would see that when we are looking at binary based, like binary search, you would apply log B of n for your big O notation. If we're using a 1 for loop, that will be O of n, and n is the number of inputs or elements in our container. And in other cases, we might have n log B of n. So in more of a complex program above, like if you have a nested search with the sort, you would want to use a different order of growth for big O notation. Then when you move into quadratic, so when you have nested for loops, that will be O n squared, and then so on. So in the case where sometimes we would nest loops within loops within loops, right? You would force the system or the interpreter to go through, iterate through one linear, and then from the inside out, right? And so you would have to raise the exponent for your input value. Any questions regarding order growth? Okay. So in the introduction to Python courses, you're probably familiar with lists. We saw a little bit of this when we did the review during the first week. So a list is just a container. It is similar to array in C++, but Python, using NumPy, we would be able to implement array. And we would use the list as a collection of elements. And so you can add elements, you can remove elements from the list. So it is a resizable array, hence very similar to dynamic array in other languages. Now, when you're modifying the elements, it would need to go and access specific index. And we talked about O of 1. So the location of the index for your elements is important in a list or specific container. So if I have a list of 1,000 elements, my O of n, that would refer n as 1,000. So that means that the list needs to increase the size to really accommodate 1,000 elements. Now you can also make it grow, right? So for example, I can write a loop, and as it obtained the value, it would insert that value into a list that is empty, right? And I can do it 1,000 times. So by the end, I would have 1,000 elements. So your list can grow and it can also shrink. So when you do that, you're really appending individual element, but as you loop through, that will be O of n because it's 1,000 times that you append those elements into the list. So in this type of industry, you normally see that this is a linear approach. And we can find other ways to really write our data structure or create a data structure that is more efficient. Why do I have to insert at the end? Why can't I add it on both sides? Why can't I use another way to really access the container? So in the linear structure, you can only go to the tail. So as we add the elements, we just add it to the previously or the last element that was added. And when we pop, we would go to the last element and we would remove it from the list. So that will bring us to the next part here. Here you can see that this is a pop method. So you would use a list.pop. And this is what was given in your book, and that can be assessed in many different ways, and it would look a little different. So here we would have the n is 10,000, and you would see the value for the time. Where if we increase that to 20,000, you see that there's an increase in time. But then when we get to 30,000, it's roughly less or about the same. So to really access only one element, you consistently would see that it is about the same between the size of the container here, and as it is a constant O of 1. If we pop specific index, like the first element, it's going to go access that. And here in this system, it takes 4.2 seconds at a 10,000 element. And in the 20,000, we see 8.36, and 30,000, we would have 1209. So linear wise, what you would see is this is going to be the worst case scenario with the most number of inputs and the slowest time. Then when we append, if you append a value for 10,000, it's 43.43. And then here, 0.45 and 0.46. So it's roughly pretty close for O of 1. Whereas if you're looking at the linear operation for the number of input, the highest number of input is going to take the longest time. Okay, any question? Okay, so as we said earlier, we can we can use a collection or a data structure that allows us to store and access our value a little bit quicker, more efficient. So a deck is a double, or it stands for double-ended queue. This is a way that we can access the container on both sides. This is also implemented in Python as a doubly linked list. So think of a list, which is a container that stores values, but instead of going to the end of the list to be able to add values or remove values, we can do it on both sides. So you can pop and append. You can do a pop left, append left, pop. And when you do a regular pop, it's going to go to the right. And when you append without the left, it's going to go to the right side. So you can do it on both sides. So when we take a measurement of the deck, what we can see is that there's significant drop in the time compared to what you see up here. When you compare that to the deck, you do see improvement in time. So when you design your application from here on out, you have to think about what kind of container that you want to use, what would make your program more efficient, and how you're using storage is very important for software engineering and software design. Okay, so in this case, when we're pop right, we just simply do a pop, so it goes to the end on the right hand side to remove, and that's 0.41 for the 10,000. That's 10,000 elements. Okay, and as we look at the 30,000, which is the most, right, there's a slight increase, about 0.10, and that's O of 1. And similarly, you can do a pop left, remove from the left. So roughly, you do see the time measurement is about closely the same for O of 1. Any question? Okay, so here again, it shows O of 1 for the time. And then if you are implementing O of n, so you do see a drop in time compared to what we seen earlier. That will be like 17 point something microseconds, where this would be a lot less. So when we look at how we would implement search algorithm, and this is so important for computer science, and even overall when you are looking at application development. So there are many many algorithms that you can implement for searching. Yes, you can just loop through every single element, and that we'll call a linear search. So when I teach discrete structure, I talk about that. So if you implement a for loop and access every single index to look at the value to find the matching value, you would rely on O of n operation. So you can use list index method for the search. Now, as you know, Python community is quite large, and so there are developers that provide libraries or modules for us to use. So you can speed it up by doing a sorted. So if I have a pre-sorted array, it would be easier. So let's say that I have an array of 1 to 50 as values. And if I'm looking for 30, right, it is simpler to really have it pre-sorted. So what we can do is for Python, we can use a module called bisect. And bisect allows us to do fast searches using sorted array. So what it does is we can use the function from this when you use bisect.bisect. it allows you to sort the container or the list. And then find the index to put that element for the array as it is pre-sorted. Okay, so the way that you write this first, of course, you got to make sure. So if you're using Linux or any IDE, you got to bring in the library, right? Because it don't just, when you're using third-party library, like outside of Python package, you have to make sure that it's there. So if I'm using Tawny or code, right, VS Code, I got to make sure that I can identify the library and link it to my IDE first. Okay, then we would write an import statement. So we can say import bisect. Here is our list, name collection, 1, 2, 3, 4, 5, 6. And if we want to search for the value as 3, you can do a bisect.bisect, and then name of your list, use a separator, and then add the value. So here, what you can do is it's gonna be able to access this, right? And search for that value quickly using bisect module. Now, this list is simply small, but in the case if you have a very large container, so for example, I can use random module and generate random values for 50,000 elements in a list. And then I would be able to use the method to access that list and find the 110th element value quickly. Okay. Now, you can go to the module and look at the information and various methods that you can implement. So in this class for this assignment, I go over the general information for the module. But in the future, if you want to use this module, I highly recommend looking at examples and the methods that's implemented, right? Like what the function does. So it does the lookups. Okay. So in the case, if you do like a shopping cart for online purchases, and you might have thousands of products, right? And a customer would search a certain keyword, and we'll talk about dictionary in a little bit, key with the index. So if they search by keyword, right, it's going to go to, of course, like a database to be able to pull. But from an application standpoint, you have to really point it to the container and how you would be able to retrieve that from that container. And so you have to implement the algorithm to access the database to be able to pull specific items as they search. Okay. And on the simplest level, we would see that in a list container like this, not implementing the database, of course, but we can look at how data can be used for SN search using bisect. So for number 4, what you would have is you can refer to the documentation. And what we want to do is we want to write a Python program that uses bisect module to accomplish the listed task. So first, we have a list called for test score. So here's the student test score. So we want to sort it. Okay. After we sort it, we're going to use bisect function to identify the position and insert an element. So as it's already sorted, right, this is not pre-sorted, so we have to sort it. So 42 is going to go first and so on. Then we're going to add 86 into the appropriate sorted container. And we want to display where it was appending or inserted. Then we are going to use the list as a doubly linked list. So we are going to go to the left and we're going to find the position to insert 40, which is going to go before 42 in the sorted list. Then we're going to go to the right, and we're going to insert 91 as it is a highest value on the right side of the list. And so I just need screen capture of the script and output. So I'm going to walk you through my example, and you can write it similar to it, but do write your own code. So we would start with the import statement. Let me put a comment on top. 3. So we would have an import for the import module. Then I would have a test score list, and I would keep it like how it was given: 60, 61, 90, 42, 78, and 85. And Python has the sorted method, so you can simply use test score and reassign it the sorted of test score. So at this point, I would sort the list and I print it. Then after that, what we will do is we are going to use the insort method from bisect. And for the parameter, we simply pass the list, which is now sorted. And we want to look at 88 and the position. So we want to print it out. Okay. Then next we are going to do an insort left. I want to make sure that I have a matching value here. So I would have a 40. $86, $40, and $91. Okay, so $86, I have $88. Okay, so on the left, what I want is, because 40 is lower than 42, so I want to look at the values, right, position from 0 to 6. And I wanted to make sure that I access the list and be able to add in the 40. Now, do you notice why it's 0 and 5 here? Is because if you count up the elements, there are 5 elements. We start with this, and we're going to go past index 4, which is we end with index 5. Python is usually like that. And then for the next one, because we already added 86, which gives us 6 elements, so you have to go to 0 to 6. And so as we add to the left, right, we go from 6 elements to the next step, which is 7. So we have 7 elements here, and we're going to add 91 to the right-hand side. Okay. Now I'm going to try to reinsert 86, and so you can see. And at this point, when you do the last step here, you see that we would have 8 elements total. So let me run. So we first printed the sorted list as we force it to sort here. And so I have a sorted list. Then in the next step, I added 86. Okay, so it drops it after 85 here. And I simply use an insort. And I want it to go from index 0 to past the last index, which is going to be 5. And then on the left side, I wanted to now add in the 40. So again, I have an additional element. So now I go 0 to 6 and it added the 40. And then on the right side, on the next step, I wanted to add 91. So it added the 91 and it still gives me the sorted list. And at this point, I have 7 elements. And then lastly, I tried to reinsert 86 again so you can see. Let me correct my comment here. So when I reinserted 86, at this point, I should have a total of 8 elements. So it did that here. So I have 286. As student would have the same score, unlike sets, right? Where sets needs to have unique values, lists, you can repeat the values. Okay. So in this case, it's a lot easier to use the bisect module versus writing for loop for every single one of them. That saves you time because it's already been invented, this library. We just simply tap into the library and use appropriate method to be able to change our container by adding the values. You can also remove as well. Okay. Any question? So as you go through the step, you have to be mindful of how your container is growing, right? As you add to the left and the right. And we simply use the insert left, insert right. So if it's in the middle, we'll just do an insert. If it's on the left-hand side, you can do insert left as it is a low score. If it is the high score, we can do an insert right because it's on the right-hand side. So we have to be mindful of the function that we use from that library and how our container is growing. And this is to address exercise 4 from assignment unit 3. Any question? Okay, pretty easy. So after you write your code, you can simply run, take screenshot of your code and your output. If you're using an IDE, that would just be one screenshot. I just want to see that you successfully ran that. I'll update your grade throughout today and tomorrow. You have it ready by Thursday from last week assignments. Okay, any question on 4 before we move to the next one? Okay. Like many of other languages, when you approach, right, like a search type of mechanism, it's always good, especially if you're using linear approach, meaning that you iterate through and seek the value. It's always good to look at sorted, right? Have it pre-sorted. I know C++ also have mechanism for that and Java as well. So we want to approach it with the sorted container, and then we can use appropriate method or function to be able to access it. So when you look at the time complexity for one task like this, right, that will be O of 1 to execute each task. Okay, so we saw, so this is the format or the structure, I should say. You have the list name, the number that you're trying to append, right? And then the beginning and the end of your list. And here I put a note that when the element is already there, it's already present, the most right position of the element is then inserted. So when you're looking at my program, remember the last step we did 86? So the newer 86 is going to get added to the right, even though we're using the insort method, okay? So it's going to drop it to the identical 86, but on the right side of that. And the list can shrink and grow, of course, depending on what you're trying to do there. But in this case, we're growing our list. Okay, so let's come back here. And then so you can look at how bisect left and right is used also. So for number 5, we're going to use the sorted list from number 4. And again, we are going to use, did I use insort on this one? Hold on one second. I show you number 5. Sorry, that was number 5. Let's do that again. There. Okay, so for 4, we would do a sorted list, print the score. And then for this one, we would do a bisect. So when you do a bisect, it's going to insert that value into this, right? I don't have an 86, so we're going to sort it, insert 86. And then we're going to insert 40 to the left and then 91 to the right. So when I run this, you would see that first, when we sort it, we use the sorted method for Python. So it's going to give me 42, 61, 78, 85, and 90. And when I use bisect, when I added 86, okay, what I have is it's going to tell me that it's going to be in the position. So 86 is going to go right there. I'm sorry, right here. So 0, 1, 2, 3, 4. So 86 is going to go after 85. So it tells me it's index 4. Then on the left, when I use the bisect left, when I insert 40, I want to know which index. And of course, 40 is the lowest value in the sorted list. So it's going to drop it before 42. So it's going to be index 0. And then for the next one, 91, when I insert the 91 on the using bisect right, it's going to tell me that it's going to put it into index 5 as it would be after 90. Okay, so 0, 1, 2, 3, 4, 5, 6, so 5. So when you're using bisect, the return value is going to be your index. Compared to the next exercise, when you're using insort, right, you can also provide the index. The only time that you would be able to print this out again is you would want to print out the container every single step, but you don't need to do that. The assignment actually called for it. So here you would see that bisect doesn't require additional parameter. It doesn't require the beginning and the end. Whereas when you're doing insort, you have to put in the beginning and the end value. Okay. So if you're using Python to do data analysis, this is a quick way that you can add data, right, to the container. And then instead of like looping through non-sorted value and seek the value and then find space to add it, use bisect library to be able to do that. So again, for number 4, right? Do a sorted method, print it. After that, declare a variable, and that variable is going to store, right, the output of the bisect method using the bisect module. So you would do a bisect.bisect, and then your list name, and then the value. So for 4, you don't need the third and the fourth parameter, as it doesn't require the beginning and the end. It just assumes, right, the size of your list. Then on the next step, after we insert 86 and find the position that it insert, which is index 4, we would do the left side. So because it's a low score, we're going to do a pos left for the variable, and it's going to store the output, right, which is an index of where it insert the value 40 on our list. And then for the right position, it's going to store the index value of our inserted position for 91, which is going to be the fifth, the index 5, the 6th element. Any question? Now, if you want to get rid of it, right? If you want to get rid of 91 or the far right, you just do a pop. And if I want to get rid of the first element, I can do a pop left. And then for specific, like if I wanted to pop 42 or 78, I would just pop with the past the index value. And that's how you can remove. Any question? Okay, so that's 4. And then I think I touched on 5 earlier. So 5, again, we sort the list of the test scores. Then we're going to use the insert method. But for the insert, you're going to make sure that you use additional parameter, the value. So the list name, the value, the beginning, and the end index. So index 0 through index 5. The same thing for the left. We would use 4 parts parameter, list name, value, beginning, and end. And our list is growing. Any question? So you can refer to page 4 and 5 for those exercises. Okay. Now for number 5, this is just an added step. Okay, so that's not required. You only get to the 91. So I did the reinsert so I can show. Any question with 4 and 5? Hold on one second. Someone's at the door. has until 7. You want to wait? Okay, just have a seat. Okay, any question regarding 4 and 5? No questions? Okay, we're going to continue. So in the next part, we'll talk about dictionary, and dictionary is implemented as hash maps, as you can see here. So hash map is a data structure, and what it does is it's going to associate a set of key value pairs. So it's going to use an index for the key. As you know, the dictionary uses key. So my key can be shirts, and then the value, it could be 50, right? So what Hashmap will do is we can generate a value that represents the index for that key shirt. So when it's using the hash function can be used for all kinds of data types. So in this example, what you would see is when we can use hash hello, and this is the output. Okay. Now, if you want to have restriction, the author shows that you can use modulo, and that is the percentage symbol. So instead of the result like this, when you're using the operator, you would see that it's going to narrow your result down to less characters. Now, the challenge with hash is going to be collisions. So that means that you can have the same hash value or code for different objects. So we want to use it efficiently for the dictionary. Now, what we can do is we can use the collections module and then be able to use the default dict in order to apply hash maps. Okay. So the example of your script would look like this. So you would say from collections, import default dict. And this allows you to implement the function or the method. And dictionary is a container. So in Python, anything above 2 dimension, we want to use dictionary. Okay, you don't want to use 3-4 dimensional lists or array. That's just too complex. Use dictionary. And we can implement Hashmap for the dictionary. So basically that identifies the location, right? The index for our keys, which store data. So in this one, we would have a counter, and we use the default dict method, and we would use integer here. Okay. So for this function, we want to set up the counter, and then we would use that counter in our for loop to access your item. And collection module also have a counter class. So in the library, as it's written in Python, you would have counter class. So if you want to access that class properties, you would then import in the class, create an object, right? The class object. So you instantiate the object and then use that object for your program. And here shows you the time complexity using counter in collections module. Okay, so this is another option for you to implement with your data structure dictionary. And we would use collections module, and inside that we have counter class. And you can always go to the documentation and look at example and the methods and how to use that particular module. Okay. So let's do a deck for 6 and then answer number 7. So for number 6, it says refer to deck documentation and write Python program using collection module to achieve the following task. First, we are going to create a new deck that contains 3 items. That will be your characters CDE. We're going to append A and B to the left side because that will go before CDE. AB is before CDE, and display the updated list. For step C, we're going to append F and G to the right side of the container and display the updated list. Then we are going to use the extend function or method to add H through L and display the updated list. We will use a rotate method to rotate the deck from left to right. So you're going to flip it. So instead of going from A through L, we're going to reverse it. So it's going to be L through A from left to right. Then after that, we're going to pop. That's going to remove the right item, and then pop left to remove the left. So the most right and the most left items are going to be removed. And then we're going to do a clear method to empty everything in the deck. The reason why I show you this is some of you will go into data science or some of you will need to know how to do this to implement in your application, whether it's, script for cybersecurity, right? Or, in software. So we want to really look at how we can create data structure in different ways so we can implement that in our algorithm for our programs. So let's take a look at 6 together as we're clear on the objectives. Let me clear my output. So deck uses collection modules. So you're going to do from collections import deck. And we are going to create a deck called DQ. So you simply give it a name. You don't have to call it DQ. You can call it my deck or deck 1, whatever. And because it is a deck, right, because you import that in here, so you have to use it here. So deck and then our deck content, which is CDE. As it contains multiple items in that container, we would implement a for loop. So we would say for element in DQ, we want to print the element so we can display our content of our deck. And we do a print. So you can do a for loop to print, or you can do a print and simply do a DQ. So Python has multiple ways, of course, right? If you print out this deck, it's going to show both ways. Then we are going to append left to our deck. So we're going to add B and A. Why do I add B first before A? Because it's last in, first out. So I want to put in B because B goes after A. So it's going to put B first here. And then the next step, it's going to add A after B. If I do A and B, A is going to be after. So it's going to be B, A, C, D. That's not what I want. I want A, B, C, D, E. So I'm going to have to append B first and then A. So we have to be thoughtful about the order of our items coming in as elements. Okay, so we're going to add that before C, and we want to print again. So you simply print DQ, which is your deck name, and it's going to show. Then after that, we are going to append F and G after E. So when you do append, it's going to automatically add to the right, whereas you do append left, it's going to add to the left. Similar to what you've seen with insert in the other module and bisect. Okay, but in this one, we only need to have the value or whatever that we're trying to append. So when you're doing individual elements, you want to use append to insert them each. When you're doing a group of elements to add them, in this case, on our next step, we want to add H through L, you would use extend. And that's simply drop in H through L after G, because that was the last step. Okay, so extend allows us to insert additional elements, but as a group, whereas when you're doing append, it's individual element. And then if you want to rotate right, you're gonna pass the 1 using rotate method. If you rotate left, you are going to do a -1. And then lastly, I'm going to remove the last element by doing a pop. Okay, so pop right is going to be a pop. So dq.pop. And then on the left, if I want to remove the first element, which is the most left, I'm going to do a pop left. Then in the next step, we are going to clear and reprint. Okay. Any question? Okay, so I'm going to show you the display and run through it again for those of you who just got through this. Okay, so we talked about import statement. So when I did the for loop, notice that it's going to print individual as it loops through. So I have C, D, E. Okay. But if you want them all together in the container, it's list nested. So you would see that CDE, when you do a print and then your deck name, it's going to do like this. It's going to give you the entire deck in one line. When I add AB on the left, so that will be AB here. And when I print my deck name after that, it shows A, B, C, D, E. And notice I talked about adding B before A. So B goes in first, and then it's going to add A after that. Okay, you don't want to do it in reverse. If you do A, B, it's going to do B, A, C, D. And we want it in order, so we're going to do B first and then A. Then I'm going to append F and G to the right side. So F and G. As it is on the right, I can put F in first, so it's going to add F. And then after that, it's going to add the G. And print our deck. Now, in the next one, we're going to do a group of characters. So we have to do extend. So when you do that, right, we left off at G. So when we extend, it's going to drop in HIJKL. And in the case where if you need to add more, like hundreds of values, you can do extend. Okay. So it's extending our container. So I'm going to do a rotate right. Okay, you notice my L is on the right side. I wanted to flip it and put it to the left. So when you pass a 1, it's going to take the last element, which is L, and it's going to bring it to the left. Okay. So L, now drop it in the front. And then I'm going to do a rotate -1. I'm going to do a rotate left. So it's the L, and it's going to put it back into the back. Okay. Now, if we want to flip the entire thing, right, we just send it through a loop, and it's going to keep doing that for us. And so when it enumerates, or when it iterates through all of our characters, 2, 4, 6, 8, 10, 12 characters, you can completely flip it by looping it 12 times, doing a rotation. So you can do rotate with 1 and put the rotate inside a loop, like a for loop. You can do it 12 times, and it's going to flip every single one. So we would have a completely flipped list or deck. So when I did a 1 and a -1, it just put it back to where it was, right? Because it took L, put it in the front, and then put L back. Then we are going to do a pop left, or a pop right, I'm sorry. So we're going to pop L. So now we're left with K. So 1 less element. And then we're going to do a pop left, which is A. So it's going to it took out A, and we're left with B. So 1 less, 1 additional that's dropped off. Then we clear it completely, and we ended up with an empty deck. So when you print that, it'll just show that it is there. So that means that the storage is there. Your deck is named DQ. It just doesn't have any elements inside. Okay, so it ties the memory address to that identifier that potentially can contain elements in the container. Any question? And so this is using collections module. Okay, and deck in collections, because collections have many submodules that you can use. Question? Okay, so that was 6. I walk you through every single step. So all you have to do is just to code your own and then run through so you can have a better understanding. So the whole purpose of walking you through the exercise so you can see, and I hope to explain that for you so you can be clear and remember how to use it. Okay. All right. So in the notes, it talks about Hashmap, and we touch a little bit on it. So for Hashmap, this is used in dictionary element. You can use it to insert, delete, or even access values. And so Hashmaps allows us to associate key values pairs. It's going to assign a specific index or hash code to each key. And the key is then associated with the value. Right? So I can say my key would be course, and my value would be CIS30E. So when I use Hashmaps, what it will do is going to give me a value that represents my key, which is course, and associate that to the value, which is CIS30E. And so how can we generate that index value? We would use the hash function, and that can be applied to different data types. So in general, what we can see is it's allowing the system to use a hash value to identify the location of where it stores the dictionary key and its associated value, like course and CIS30E. Any question? We're getting close to being done, so it's not too bad. Okay, just a few more. Okay, so I put a link here for the default dict. We talked a little bit about that earlier. And you can always come back here to look at default dict. That's on page 5 through 6. And I will walk you through the next exercise. So for question 8, it tells you to refer to the documentation, and you're giving a list as a default factory using a default dict class. So in this list, and I try to make it where it would be associated with like realistic example, where let's say that we own a t-shirt store online and we're trying to implement the app in Python, right, to seek, right, different shirt sizes or shirt type or shirt size based on the number of t-shirts that we have. Okay, so we have our default factory, which is called shirts. It is a list with, and as you can see here, that it is, we nest it with the key and the value. So I have extra small, I have 20, small, I have 15, medium 50, small 60, I have 2 small, right? And then large 80, medium, again 65. And so we have variations. Sometimes it's repeating with different value. And when you look at a data analysis standpoint, it's not clean. It's going to be like that. Sometimes it's repeating with different things. So we have to work around it. So we want to just use the default dict class and be able to give out the sorted list. So we want to make sure that the small together, the medium together, and so on. Okay. But remember that this is string. Okay. So sorted will be based on the string, how it is displayed. Let's clear this. All right. So here I have my import statement. So you want to go from collections, you're going to import default dict. Then I would generate the container here. So I create the container shirts that's given to me in the problem. Extra small 20, small 15, and so on. Then I want to convert this list into a default using default dict method and stored in D. You can call this anything you want. Just make sure that you use best practice when you identify, right, location to store. So here I use D. and I would use the default dict method. That's what the problem asks for. And I would use list type because referring to my container. So then I would then use a for loop. Now notice that it is nested. So you have the list on the outside and we nest on the inside. So I have to use two variable I and j. So I can say for I and j inserts. I'm going to access I and I'm going to append j. Okay, using default dict. Then I want to print out the sorted container at the end. Now it is alphabetized, so large is going to go first, as in L is, right? And then M, S, and so on. It's alphabetized, A through Z. Notice that as I send it through the loop and print out the sort, my large is 80. Check here that I do only have one large, and that's 80 shirts. My medium, notice that I have two medium. One was 50 and one was 65. So it combines the medium and it grouped the values into a sublist. So 50 and 65. Also sorted. Then I have two small. One was 15 and one was 60. So now I have small and it again group it into a sublist and it has 15 and 60 sorted. And then lastly, my X small, because X is later in the alphabet, so it drops it back here. And so I have X small and it has 20. Is that a list of tuples? Yes. I am confused because dictionary uses curly. Yeah, so on here, we start with shirts. It is a list nested tuples. Okay. And then when we sort it and when we send it through we append and sort it, what we did was we nested again. So you have a list with the tuple and nest with the list, because tuple content cannot change unless you put it into a sublist inside the tuple. That's Python rule. So to combine the medium, it cannot be combined as a regular tuple inside the list. So what it did was it would put, we have to put it into a sublist inside the tuple inside a list. Because even though it's default to dict, right, it's a default factory, so you're not fully using a dictionary, right? Dictionary would use the colon for after the key. So if I want to use this as a dictionary, I would use a curly brace here. That would be my key. And then the value, it would follow the colon. Okay, so syntax is a little different. So you are right. It is tuple inside a list. And when we append and access the sorted item, it again nested in the list inside a tuple inside a list. And that's our output. So ultimately, it is a list with tuple and sublist. Yeah, no problem. You can use the dictionary for this, right? So to use a list, it's limited. Okay, in a dictionary, as dictionary can, you would implement dictionary anytime that you would need multi-dimensional lists. So anything after the 2-dimension, you want to think about like, creating your structure, your data structure to really represent how your program objective would be, right? So I would have key and value, and I might have like school, course name, room location, class capacity, and so on. Let's say I wanted to do a schedule application for a school. In that case, I would use the dictionary because, you have so many different levels of elements that you want to nest inside the container that it's more efficient to use the dictionary. Okay. So collection is pretty cool. It has, lots and lots of capability. So this is, what I wanted to show you, what you can do with the list using collections. And in the last, we used deck already with collections. So you can think about how you want to use your data structure. All right. Now we're going to do a Python program for 9 to do the inverted index. And in this one, we want to search, our key term that we want to search for is brown. Okay. So in 9, we have a list of animals, and they are identified in strings. So brown cow, black cat, yellow bird, red rooster, brown horse, white rabbit. We are looking for brown, so we would need to seek brown cow, brown horse, right, by looking at it. But let's say that in a more realistic sense, you might have lots and lots more of elements that would be brown, right? You can have a brown snake, and so on. So I want to use this example to show you how you can use inverted index to search for brown. And I think I covered this in 30A using a similar example with fruits. Okay. Let me get my 9 open. That's clear. Pull this down a little bit. Okay, so pretty easy. This one takes a little bit of nesting the loop, but here we start with defining our list, animals, and we would use the one from our exercise. I want to show you this part is just regular iteration. So if you want to do just iteration, a linear O of n, right? Linear, the big O notation is going to be O of n. Then you can simply do a variable. I call this seek. And I would say color for color in animals, if brown in color. And the lovely thing about Python is that you can write it all in one statement. It's so beautiful. And you put it into a list. And then you print it. So the simplest way to really address or solve this, right, not using inverted index, is to do this. But this doesn't meet the assignment objective. I want to show you that you can do it this way, but it doesn't use inverted index. So normally we would just loop through it and look for brown, right? So basically it's a for loop with a nested if. We would say color for color in animals. That's a for loop. If it is brown in color, because we put that in the list here, right? We print it out. Then for the inverted index, you would first define it, index, and you would use the curly brace. And I would say for I, which is our index, color, and we would use enumerate animals because that's our container. So we would enumerate through the container, which is a list, and we would access each of the index, and we want to take this color, we want to find the brown. Okay, but first, in order to do that, we got to take the string and split it into halves, the color and then the animal. So to do that, we would nest another for loop, and we can say for word and color split, if word not in the index, right, we would use index and word. So we want to be able to get the color by nesting the for loop with the if. Once we have, so if it's that, right, we would, if it's not in the index, we would access, else we would append. So what I want is I want to get just the color for each of the string. That's what I needed. Then for results, I declare results using index. Index is going to be brown. So here you would see that because it's accessing brown, like the first one here, that will be O of 1. But as it's accessing each of the element on the animals list using a for loop, you have O of n. So the second variable here, I have result words. It's actually a list. So what I have is I want to use a for loop to find the result in my list. That's brown. So what it's going to do is going to access each of the element, okay, and look for brown. Okay. So then it's going to print. It's going to tell me where it found brown and print the inverted index, which is the location from the right to left. Okay. So in the iteration, find it right away, brown cow and brown horse, right? Not using inverted index, that's there. For invert index, it tells me that it is at the first element, okay, and at index 4. And then to print the result, I would get brown cow and brown horse for the inverted index. And that's how you can implement inverted index in a search using Python. And in this case, we didn't need to really bring in any modules. We simply use Python package. And when you look at this algorithm, right, for this part, you would have O of n squared just to get it through the nested loop. But to really get our results, when you look at accessing brown and accessing the list, you have O of 1 and O of n, okay, to give us the output. So for future interview questions, sometimes that you would get simple programs, something similar to this. Sometimes you would get more discrete structure type of questions that would require a little bit of, mathematical implementation. But you need to really dissect what the problem presented to you and think about how you would approach it. Can I solve this another way? Yes, right? I show you that we can do it this way. We can do it with an inverted index. But there are other ways. What if you implemented binary search? If it's a larger container, I would consider doing that instead of doing a linear with the enumeration. And so on. So you really have to think about like the size of your container, how you can efficiently address, right? Because this is a fairly small container, even though it has strings. And Python has like plethora of different ways that you can access strings. Okay. So I can find data using this approach in like string format. All right, questions for 9. Okay, so that was 9, and then we just got to do a few more for the last part. So flipping back to the notes. So here it talks about inverted index. We saw the example in question 9. So you can seek a certain value. It is a way for us to use strings in a list. This is the best approach for Python. Okay. So with that, what it would do is it would be able to map. So when we say map is it's able to identify the actual storage location or memory addresses that's associated with the elements in your container. And when we seek that, it can go to the address and be able to give you what you're seeking. And in our case, brown for exercise 9. Okay. And so this is basically the format that I use for my program. So you can refer to page 7, right? I basically use this, but instead of append and different things, I modify it a little bit. So I still use enumeration. I did a split. I use index word, append, and so on. So I use this example to create my program. We talked about sets last time, right? Sets store unique values. You can, in sets, there's frozen sets and there's immutable and mutable sets. So mutable sets, right? You're able to, or a frozen set you can't change. Mutable sets you can modify. We spent a little bit of time working on sets in the last unit. So there's some additional example for you to use. So sets allows you to look at like, union, intersection, difference on both sides. For heaps, and you probably might have learned this in C++ or Java. Okay. So heaps is also a data structure. This allows us to extract maximum and minimum value from the collection. It's really designed to really identify the values that's maximum and minimum. So the example that the author mentioned is looking at the maximum priority for the heaps. And heaps data can grow and shrink just like a lot of the other structures. So if you're accessing only the maximum value, to remove it, then it will be O of 1. If you have to go through the container, it will be O of n if it's linear. So sometime that would be log of n. So if you're doing like binary, where you cut things in half and half and half and half until you get to what you're seeking, so that will be log of n. And for Python, the cool thing is you can use Heaps module. Okay. Some example using Heaps. So you can have a container like this. You can use Heapify method that allows us to reorganize or sort it. Okay. You can also pop from it, remove. You can push. So pop is to remove, push is to add. And then there are other methods like put, get, and so on. So in the case where if you want to implement for Q, right, you can use also Q module. So this chapter provides you with options on how you would be able to implement your data structure. Okay, a little bit of the try information. And so this is implementation using PyPy. Try does not include for the 3x version of Python, so that was removed. But in caching, as most of you know that our system cache, so things that are regularly accessed, your system store it in a temporary location called cache. So this can be on RAM, on hard drive or SSD, or on another system like server, cloud server. Web application cache all the time. So for example, when you're playing your game on your mobile device, right, how does it know where you left off on the game, right? Some of that is stored, or even your credential information. So game status, credentials, sometime like data, scores, and so on. Now, in the back for development in Python, when you're storing and reusing the results from the function call, this is what we call memoization. This is a form of caching where it would map back to the location of the data, where you would store things temporarily and be able to retrieve it from your function call. So we would take advantage of this to improve our performance. And because your storage is dynamically, right, stored in the container, we want to also implement this for dynamic programming and using memoization. Instead of keep storing the same information again, it just goes to a location where it's cached, which frees up some memory for us. And that reduces the amount of resource and the retrieval of the data at those additional resources in your application. So for those of you who are in security, you can think about this in, right, for network identifications and so on. There's a lot of like network status in, even for web server, we'll touch a little bit of that in here with HTTP and framework. So that cache information is important because if you are still connected to that part of the network, it doesn't need to reestablish the connection again. As some of you know, that when it does that, there's a three-way handshake sometime that has to be, right, communicated with Synapse, where it would make sure that connection is recognized on both sides to have communication. So you can use functional modules for cache decorator. And anytime you hear the word decorator, it uses the @ symbol for Python. So this allows you to use the functional modules. You simply input in the LRU cache method, and you decorate it for this function. So use the decorator as you define the function, similar to what we've seen with, how we create profile last time. Okay. You can specify your cache size because we don't want it to grow too large and it's going to become a resource problem. So they show you the example here running Fibonacci sequence, and Fibonacci simply takes the two prior numbers starting with seeding at 0, 1, or 0 and 1, or 1 and 1. So you add 0 plus 1, you get a 1. 1 plus 1, you get a 2. 1 plus 2, you get a 3. So you just add the two previous number. So for Fibonacci, right, you would have O2 of n. Your big O notation is 2n. So when we look at the time that requires in the example, we would see that it would take less than 6 milliseconds, a little bit less. And so you can implement like iteration, recursive function, or using a module, and you can see 3 approaches which produce the best time. And you would see how algorithm, right? Because in the last chapter, we talk about code and recode, code and redesign your code. So you can write 3 versions of your application using 3 different approaches and look at your time output for the same purpose, and you can see, okay, is recursive functions going to give me better time, or would I be able to use the cache or the memoization to give me better time? So based on the author's perspective, right, using the example, LRU cache decorator provides the best time. Joblib module is also used for memoization, and it uses memoize function. So this is another module that you can manage your storage. And again, we can use decorator, and this specifically focus on cache. Okay. Now, whether, there's so many different ways that we can apply this in the regular applications, in game development, in cybersecurity. We can use this for a lot of things, like for scans, network status, for even like for ethical hacking, we can script it to cache some of the information so that way we can reuse it for attacks. So in either way, if you know how to implement the module, I think it is helpful to really maximize the capability of Python. So as we are getting close to the end here, we should answer number 10. Why cache is useful in development? Because it really improves your algorithm by storing and reusing data that's already computed. I don't need to recompute the data that's the same or the same process again to execute that, right? I can just go to a location to be able to retrieve it. And in many cases, right? Network connection, reestablish, certain player status. You can just reuse the data where it was stored. So caching is definitely going to help us reduce resource usage and reprocessing for our application. And for 11, the module that can be implemented to use memoize functions for caching purposes, you can use joblib module. And in that, you would use memory class. So you would instantiate the object, right, under memory class. So I would say from, right, joblib import memory. And then I would define my object like C is, right, memory, and then pass whatever type of data that I want to use. And then through that, you can use the functions. So check out the documentation. And then for 12, how can you efficiently create and comprehend a dictionary in Python? And this is coming back to what we talked about in the last 2 weeks. You need to first define a method or a function that uses map and generator to access the elements in the dictionary, because it is a container that has different elements within using key and value. So that's the best way to use to create a dictionary and comprehend it. So when I say comprehend a dictionary, that really means what? To access the content of the dictionary. Okay. So in the lab this week, we'll focus a little bit more on what we're learning this week. If you're still working on the last lab, try to get that to me. I will make sure that your grades get updated by Thursday. And then so you have updated grades for the week. If you have any questions or challenges, let me know. Okay. All right. Any questions regarding the last part of the exercise or for this assignment? Okay, so type your name into the chat. Thank you so much for your attendance today. I'll add your attendance tonight or tomorrow. Let me stop recording. I'll stick around for some